Hello and welcome back to another video series. In this video series, we are going to provide a little bit of lecture based on the introduction to control system. We will look at what is a control system, why do they call control system, and what are some of the components in a control system. We are also going to look at the type of control system that we have from basic to advanced, and we give you some example of the application of the control system. And finally, we look at the basic concept. Why is control system so important in many of the system that is available now and for the future? So thank you, and you can stay with me to cover all this content in our video series. What is control system? We can briefly describe control system as a set of device or component that manages, command, direct, or regulate the behavior of other systems to achieve a desired result. The keyword can be identified from a control and a system. Before you understand what is a system, previously we talked about some of the electrical component such as passive component like resistor, capacitor, inductor, MOSFET, and so on. They are the building blocks, and the component can be also described in terms of analog component or the digital component. Those electrical components, when we put them together to form a circuit, it forms a device. And when we interconnected those devices together, they form a system. So a system is nothing but a complete package of any analog or digital component that are derived basically from the initial stage of the combination of the electrical component. Let me give you some example. We have components such as amplifier. So amplifier is an electrical component. When we put them together with resistor and a capacitor and a transistor, they can form the device. And this device can be known as a sound mixer. For example, when we put multiple sound mixer together, they form a studio. For example, a studio where it composed of multiple instruments that basically deal with mixing of the sound. So this studio can be regarded as a system which are derived from basic circuit. There are many examples of a system that are surrounding us. Example, electrical system. When you look at electrical system, you should think of a simple basic electrical component that are put together to form the system. And it is important for you to understand this small example before we proceed to learning what is a control system. Since you can be able to know what is a system, we can include control. So control is all about manage or giving command or regulate the behavior of the system. In that case, we have a system here. For example, we want to provide automation to the system. That means switching on and off as an example. switching system on or off without any human interaction. Then we can consider by applying control to this particular system. Or we want to get the behavior of the system with respect to the response, how the system will respond in different environment. Then we can also design a control for this particular system. The behavior or the response of the system can go in line with the stability of the system. We will talk about the concept and describe why we need control system and why stability and accuracy in a system is important. That's where we have the control system in place. Without a control system, it would be very difficult to manage a system. A good example is a set of law. We know that in a country there needs to be a law that governs the behavior of the people. Imagine a country without a law. People will behave in many different ways which we cannot control. Therefore, we need such control system as in a law that will help govern a country. In summary, we can have a system with the input and the output. We mentioned that the output is nothing but the reference. So in simpler term, a system that controls the output of a process that must match with the desired reference value. The input to the system can be known as the reference or a desired value. That means we apply an input, that means a command or a direct regulatory that the system must comply in order to produce the response or the result. So this is a basic summary of understanding what is a control system. A control system cannot operate without a desired value. That means a law that must be put in a community as a system that we want the output. That means the people has to comply with those desired law. Inside the system, we are now going to look at the key component that makes up a control system. In order to see clearly the key component of a control system, we'll describe in a graphical representation or a diagram that compared to the types of control system. So it will be very easy for you to see clearly what we mean by the key component. So there are two main types of control system. One is known as the open loop control system, and two is the closed loop control system. So in order to identify the component, I will draw the control system graphically and we will name those components. In the open loop, we have the input, we have the controller, we have the plant, and we have the output. Similarly, in a closed loop, we have the input to the system, we have the controller, we have the plant, and we have the output. And the only difference is a feedback path. This is plus and this is minus. This is known as the feedback. The key component we can name. One, they both have the input. Two, they have the controller. Three, the plant, or sometimes it is known as the process. 4 is the output, and 5 is nothing but the feedback. The first one is known as the input. The input is known as a reference or a desired value. This term can be used interchangeably, but it is nothing but referring to the input of a system. And what is a controller? A controller is known as the brain of the system, where it is responsible for making decisions based on the difference between the output and the input. So this is the basic function of a controller. And what is a plant? A plant is nothing but the system under consideration. A system under consideration or a system under control. That's basically the plant. And the output is the actual result of the system, and it is mostly regarded as the response of the system. So this word also will be used mostly, but it is referring to the output of the system. The feedback is the actual result that is fed back to the controller. So it is like a sensor that monitors the output to be compared with the input. Without this feedback, the controller won't understand what is happening at the output. The input will say, I want to do that. But the controller will understand the input, but it won't understand the actual result from the output. Therefore, we need this feedback in order to send information to the controller to compare the input says like this, and the output must also work in relation to the input. From our example, the input can be a set of law that governs a community. So, in order for people to abide by this rule, there must be someone that has to see what is actually happening in the community. So by then it will report back to, for example, the government or the law creation personnel, so that they can adjust. If people are not following the law because of some changes in the environment, some changes in the behavior, then they can regulate the law. So in that case, the feedback becomes so important. Also in life, we also need feedback to reflect on our performance. So this is the same thing that is adapted by the controller or the control system as a whole. Now, if we compare the closed loop control system with the open loop, there are some differences which causes abnormality in the function of the control system, and which one is more preferred. If we look at the open loop here, one, it has no feedback. Number two, the output have no effect on the control action of the input. 3, it is quite simple to manage, but it is less accurate. On the other hand, if we look at the closed loop, it has feedback, and 2, we can say it can automatically correct any errors within the system. And 3, it is complex and accurate. With this difference, we can be able to choose which system is better than the other. However, the complexity also can be seen. The term automatically is very important in control system when we want to regulate the signal in a system without human interaction, that means automation come into place. That means most of the error it can correct by itself. Well, for the open loop, there is no effect on automation. If a system that does not require automation or it requires manual control, you can choose the open loop over the closed loop. And in terms of the accuracy, in open loop, the system has less accuracy, while for the closed loop, it is more accurate. When people design system, accuracy becomes very, very important. When we talk about accuracy and stability of a system, we want to operate a system normally without any disturbance that may cause fluctuation in the response or the output of a system. Finally, the complexity. Control system in the closed loop is more complex. That means it requires more mathematical information, more mathematical adaptive scheme in order to design. However, for the open loop, it is quite simple to build. When people want to choose which of the two is best, we go for the closed loop because a closed loop have more advantages over the open loop. So the choice is the closed loop system. Closed loop system is widely used in small electronics to large industrial application because of its complexity, accuracy, and stability.